Thank you, everybody, and thank you for this invitation. It's really a pleasure to be here and to tell about our story. A story that began 10 years ago, almost. We have been investigating chance since 10 years. I will mainly speak about management and politics. Then Alessio will speak about economics. And last, Alessandro will speak about talent versus luck. So, random numbers are actually quite famous in physics and in science. They were invented, their use was invented by two mathematicians, Ulam and von Neumann, but also others, Metropolis, during the Second World War, and to calculate very complicated integrals. But random numbers can have very many applications which are beneficial, and I'll show a few of them. Have you ever tried this? I'm sure you did in your life, because some noise, some randomness can help you in find the good solution. And actually, there are many more applications of randomness. Let's see. Suppose that you have a hierarchical group, okay? And you have a vacancy, and you have to substitute someone. What do you do, usually? You take one from the lower level, usually, which is the best, and you promote to the higher levels. But is this assumption that the best of the lower level works very well also at the higher level a good assumption? I don't think it is a good answer. Suppose you have a soccer team and you have a vacancy. Your forward player is missing, and you have a very good goalkeeper. Would you ever substitute a goalkeeper with your forward player? I think no, because they have different tasks. So that's the clue of what Lawrence Peter discovered many years ago in the 60s. He discovered that each position has a special task, so it's not obvious that the best at a certain position is also the best at another position. So, in fact, he wrote a very good book, and actually he announced this principle that goes after his name, the Peter Principle. The Peter Principle says that every new member in a hierarchical organization climbs the hierarchy until he finds his incompetence, his maximum competence level. He, of course, was a psychologist, so he discovered this just looking at organizations. And but actually, this means, if this is true, that each member of a hierarchy sooner or later rises this hierarchy and becomes incompetent. And there is also a Peter corollary that in time, every position tends to be occupied by incompetent people. Okay? And all the work is done by the rest of the group. So being physicists, me and Alessandro wanted to see if this was true, actually. So we proposed a mathematical model in which we modeled a hierarchical group with several different responsibilities in which you have vacancies and you have to substitute people according to a certain distribution of competence. So, and you can define a global efficiency in this way. I don't go into detail, but I mean, it's quite technical, but it's correct. And you can prove, actually, that if the Peter hypothesis is true, then promoting the best doesn't work. It's a losing strategy. And otherwise, promoting the worst, in this case, is the best. But if you don't know which will be the performance of your promoting people, then promoting at random always works. So this is the best strategy ever. And it may seem rather strange, but actually it was noted by several blogs, and it was picked by the New York Times as one of the most interesting ideas in 2009. And we got the Ig Nobel Prize for that. And this, well, made us quite popular. But this was a very robust result because actually we find it again and again with other models, even given some small percentage of random promotion. And so results are very robust. And we found also real examples of that. For example, this guy, Ricardo Semler, who was the CEO of a Brazilian company, adopted very similar strategies and made a very good job. At Google, people are paid to work by themselves on special projects, and which, if they are good, they are then proposed to the company. And last but not least, the natural selection and research work in this way. It's a kind of bottom-up strategy. So this works, although it may seem contradictory. But what about politics? There are other use, of course, of randomness. And very old, for example, Herodotus said that Persians liked to discuss the most important questions first when they were drunk, and then when they were sober. And if they confirmed what they decided when they were drunk, this was finally accepted. So it's a kind of Monte Carlo method also in decision. And so a few glasses of wine really help. And actually, random selection or sortition, you probably have heard about it yesterday, was used since the beginning of democracy in Athens, but also in other towns in Europe and in Italy, Florence and Venice, and since many times up to French Revolution. Then people was afraid of crowd and started to think of different methods. But still something remained. For example, we have popular juries and trials, and people are returning to this thing. Ségolène Royal proposed it in France. There were some proposals also in England, in Iceland, and in Canada for similar projects. Very successful. So we proposed also in this case a mathematical model with a different group, and we proposed to introduce some random selected parliamentary in order to improve the efficiency of a parliament. And it seems that this works. Actually, if you introduce on top of elected parliamentary members some people which are chosen at random, this could for sure improve the efficiency of a parliament. There is also an analytical formula. But there is also an experiment which is quite famous, which is the wisdom of crowd, which was done by Francis Galton, a statistician. And he asked to some people on a fair to guess the weight of an ox after it was slaughtered and selling 800 tickets. And if you take the average of all these cases, then what you get is an answer which is very, very close to the correct one. So I propose an experiment now. I have a small jar with beans. It's not exactly that one. You have to guess how many beans are here. You can vote with your app, and the one who will guess the exact number will win a small prize. But it would be nice to see the correct answer, the average of all the answers. It should be very close to the correct one. Okay. So let's take a few minutes to see your vote. I think we can stop and maybe show the results. The correct answer is 205. And, well, it didn't work very well, but you should take the average the weighted average. So we'll work on it. Okay, but no, just before another one. This is a website where there are all real experiments happening now in the world and about democracy at random. And I think it would be interesting to have a look and be prepared, because in the future will probably use more and more this kind of random selection for popular juries. Thank you very much.
Okay, thank you. Good morning, everybody. So our intention is to show you how much randomness can count also in economics. Can you imagine that in economics we have to think that randomness matters? So in economic systems, so it means in terms of employment, in terms of GDP, in terms of inflation, maybe the exchange rate. So something that we are so used to consider dramatically important for our countries and for the possibility to raise our income and so live freely. Yes, randomness has a role, can play a role. Let us play together. You are asked to vote for this. One of these forecasts for the real GDP growth rate for the European Union. These estimates have been selected from important institutions' forecasts. So one is the, I'm not saying in order so that you are not influenced in the choice, but one forecast is from the European Central Bank, the other one is from the International Monetary Fund, the other one is an OECD forecast, and the fourth one is mine, which is, of course, the most influential one, but I'm not saying which one. So please vote. Have you done it? Okay, stop voting. Okay. 65 votes. And this is the result. I am so sorry to tell you that the correct answer was none of the above. So none of the above, and nobody tried. Why? Not even one? Okay. That's the correct reply. No, you weren't allowed to choose it. Okay. So, but in any case, the reply is none of the above. Why? You have a second try, okay? Don't miss it. You have the reason is that all analysts have their own interest and say whatever they like, or maybe analysts are not that good and make systematically mistake, or forecasts on macroeconomic variables should be coordinated, or forecasts on macroeconomic variables are impossible. Please vote. Have you done it? Okay. Okay. Okay, let's please stop voting. Okay. This is a very, very good half of you. The other one are not enough concentrated, please. So forecasts on macroeconomic variables are impossible. But you should take very seriously this conclusion because it is not a joke. So the game is over. This is the true take-home message. So whenever you meet someone saying something about a forecast for the next year GDP rate or the next year inflation rate, you can start laughing because that guy didn't get anything. There is no reason why he should have a correct forecast, and I will tell you why, and I will give you an example. So here we have that complexity is a very important trace, a very important footprint in macroeconomics, because macroeconomics is a system where we have a lot of individuals interacting with each other in such a way that the features of the aggregate does not replicate at all the features of the individual components. So if you look at individual components, you have no information about the aggregate, and therefore you cannot have any line of causation. Therefore, you cannot predict, you cannot make forecasts, because the interaction among the parts counts much more on the final result than the individual features. This is exactly the reason why we do not have any chance to make predictions, and when singularly taken, none of us can say what exactly is going on around us. So this has severe consequences, because we have a perception of randomness in the sense that we cannot determine exactly the aggregate result of a complex system. And so we cannot predict its behavior, and we may be particularly frustrated by this, because we look around on employment opportunities and we don't find the development perspectives that we hope. So we can face this with bad pessimism. This can be destabilizing on our trust over the future. But the point is that we simply need a different class of tools. So you may have heard about the Taleb presentation yesterday and about the black swan concept. So some very extreme event, or even the other important way to tell this, which is the Dragon King, some outliers, which in a power law distributed phenomenon can always be tremendous, but that can stand in relation with all the distribution in such a way that we can infer when they are coming. But, I mean, the point here that I want to underline with you is the fact that interaction, coordination, okay, comes on complex systems, and this may create a very huge effect on the overall result. So financial markets are the example. If complexity is the reason why we cannot predict, financial market is the example that I promised to you. So in financial markets, we all know that it's a matter of opinion. The role of uncertainty, and not only in financial markets, but in all macroeconomics, was underlined by Keynes. Uncertainty makes the mess, because we cannot predict. And so every signal comes to our eyes as the very significant one. And so we are all following every single piece of news, and this comes out in a very dangerous dynamics. So there was a very nice experiment in 2001 made by Richard Wiseman. So he took the same amount of money, £5,000, and gave them to Tia, a 5-year-old baby girl, a financial analyst, and an astrologer. So he asked them to invest this money on financial markets to check the results. Okay. 1 week later, they're all losing money, but the baby girl, picking at random, okay, picking assets at random, just is the best result, okay? And the financial analyst is in the middle. But 1 year later, even the astrologer could arrange it better than the analyst. So it's a dramatic information to say what? To say that it is absolutely useless to try to dominate the market with analytic strategies, because the interaction counts more than the single laws, mathematical or statistical, that we can try to figure out. So we proposed, stimulated by this kind of result, with a colleague from ETH Switzerland. We prepared a paper in which we simulated a community of people in a small world community. Small world is a typical way in which you have short range and long range ties, but they are not evenly distributed, so that you can have a high degree of of spreading within the community. And then they simply bet on the successive day dynamics. So it was a sort of back testing. We used the true data, the true empirical data, and simply let the simulated agents live in this simulated world where that asset just were performing as the first time. So there is a mechanism that we used by a model of earthquakes, because we found that there was a strong similarity between the complexity emerging in the earthquake systems and in the financial markets. Going to results, the pressure, the informative pressure, which is distributed among these traders, and that is transmitted also by one trader to others, to his neighbors, according to the linkages allowed in the network, distributes this pressure, and so you have financial quakes when, after one trader is activated by the information going on its threshold, is transmitted to the other. So our results basically replicates the stylized fact of financial markets. For example, is the fat tails of the returns. So they are not Gaussianly distributed, so they have underneath a stochastic generator process, which will have infinite variance. So you cannot make predictions because your predictions cannot be bounded within a finite variance. Okay, so you never know exactly how it will go. Finally, we tried the strategy to put inside the community people just betting at random without any regard of any strategies. Well, we have found that the fat tails are reduced, and you can see this. This is the graph of the tail, okay? So according to a different percentage of random traders, you can see that this kind of participation is effective in reducing financial instability. And also that, by the way, random traders have also performed better than any other in capital accumulation. So even in communities, but I don't want to take too much time for the next speaker, but the point is that on the medium-long run, random strategies performed no worse than others and with a much lower risk profile. So they proved to be highly better because they share the true nature of the system. So they dialogue with the system by means of the same nature. Okay, conclusions. What I could tell you in this short time window is that predictions on macroeconomics is not possible. This is very important because when you think about policies, when you vote for policies, this means that you should understand better. You should perfectly be aware that who makes some predictions does not have any chance to get the correct result. Because if a law to make correct predictions existed, then some guy must come out with the correct value. Don't say, okay, I missed it by 0 point something. No. If you have the correct predictive law, you must give me the correct number and not once, always. That's the point. So the very, very final message is that the context, the set of interactions among all of us is so relevant that the context becomes a very relevant aspect of our lives. And it counts much more than we can imagine. And about this, Alessandro will say something.
Thank you. Thank you, Alessio. Thank you for the organizers. It's a very pleasure for me to be here. Thank you to everybody to be here. And after the incursions in the role of randomness in management, in politics and finance, let me close this our speech with a last example of the importance of the role of luck in our lives. And in particular, let me speak about the role of randomness in reaching success in our lives. What is more important to reach success in our life? Talent, as many of us believe, or luck? Let me start with taking into account the distribution of richness, of wealth in the world. Most of you know that this distribution is very asymmetric one, because this is the last calculation. The world's 8 richest people have the same wealth as the poorest 50%. This is last estimation. This is a part of a more general law that was discovered more than 100 years ago from Pareto, Wilfredo Pareto, that discovered that distribution of richness, of wealth in the population is not symmetric, but very asymmetric. Is in log-log scale, like the plot showed by Alessio in finance, is a power law, so-called power law, that is a straight line. This means that there are many people that are very poor here. This is the number of people that as function of the wealth, and a very restricted, very small number of richest and richest and richest people. So this is this rule is also called 80-20 rule. So the 80% of the population have the 20% of the total wealth, and the 20% of the population have the other part, the 80% of the richness. So if let me consider the wealth as a sort of proxy of the success. And one could argue that this asymmetric distribution in success could reflect a similar distribution in intelligence, ability, personal qualities, or also willfulness, hard work, determination, and so on. But the situation is very different from this. Maybe you know that the distribution of intelligence, for example, is not asymmetric, but very symmetric. You have an average intelligence. This is the distribution of IQ, score distribution. 100 is the average. And then the greatest part of people have an intelligence that is in the central part of this distribution. A very few number of people are very, very intelligent or very, very stupid, if you want, not intelligent. So it's completely different distribution with respect to the power law of the richness. Maybe you can think that it's so the success is a matter of hard work, the number of hours you work. No. This is the distribution of work per hours, or work hours per week. You have an average for all the population, and then you have exponential cut to something more, something less, but completely different. So what is the explanation of this very huge difference between the asymmetric power law distribution of success and the normal, this is very Gaussian distribution, normal distribution of intelligence, hard work, and personal qualities? There is the suspect that there's some hidden ingredient behind the scene. What is this ingredient, this factor that is able to change a normal distribution of intelligence, of qualities, in a very huge difference in success? People that are just to have intelligence that is a double of the norm, of the average, 2 or 3 times of the average, and have a wealth that is billions, thousands or millions, thousands of times more than the average. So what is this factor? Some people think that this could be just luck. By chance, 2 of these people are invited speakers in this conference, are Nassim Taleb and Robert Frank, with very famous books about this suggestion that luck is important in success. But there are many other evidences, experimental evidence that this is true. For example, these are a small example of scientific papers that, for example, show that individuals with easy-to-pronounce names are judged more positively than those with difficult to pronounce name for a job call conversation, okay? Females with masculine monikers are more successful in legal careers. This is half of the variance in incomes across persons worldwide is explained just by the country of residence, the income distribution of that country, without no relationship with the personal qualities. Scientists, for example, have the same chance of publishing their biggest hit at any moment along their career, without no relationship with the hard work and so on. Innovative ideas has been shown that are the results of a random walk in our brain networks. So random walk, random ideas can trigger some ideas that can go to the Nobel Prize, for example. And on the other side, 66 of probability of developing a cancer, for example, cutting maybe a brilliant career, is due to simple bad luck. So there are a huge number of these experiment evidences that luck is very important in our life to reaching success. But a rigorous proof of that hypothesis was missing. So just experimental evidences. But what is our role? 1 year ago, we proposed a mathematical model, like the previous models that my colleagues showed you. A mathematical model for showing definitively that the role of randomness is beneficial in success and failure. Our paper was immediately reached, maybe by chance, a great success around the world. And you can find, if you want, details in this our website. You can easily find by put our names. Let me show you very briefly the model. Okay, we imagine a virtual world in what we call agent-based simulations. We reproduce a very simple, very simplified model of the world in a square, okay? And black individuals are subjected, 1,000 individuals subjected to 25 lucky events that are randomly moving balloons, like points, and unlucky events, the same number, okay? Random, with random walk. The distribution, we assign to each agent a talent that is drawn from a Gaussian distribution, like in the real world. And in our model, talent is a number between 0 and 1. So it means it represents the probability of exploiting an opportunity. Opportunities are lucky events, green points. This is like, we follow Seneca, a Roman philosopher, that say that luck is what happens when talent meets opportunity. Okay, the dynamical rules of the model are very simple. We assign an identical initial capital, it is a measure of success, to all the agents. So all the agents start with the same level of capital success is the same, 10 units, arbitrary units of capital at the beginning of the simulation. So we simulate the model for 40 years, of course, not 40 years, but very quickly. In a few minutes, we simulate 40 years of working life, and every 6 months, we check if some of the green or red points are over in a little circle around an agent. This means that in the previous 6 months, that agent experimented a sequence or just one lucky event, green point, or unlucky event, red point, okay? If the agent experiments a green point, so a lucky event, his or her capital double with the probability proportional to the talent. That is a number for 0 and 1. Okay? So more you are talented, greater is the probability to exploit an event and transform it, lucky event, transform it in a double of capital. On the other hand, if a red point is found in the circle, you halve your capital with no reference with your talent. Okay, very simple rule. So we give an advantage to the talented people because they can exploit the event, the lucky event, with more highest probability. Okay, what is the result? First results of the model, we ran a simulation. At the end of the simulation, we discovered that if you report the distribution as function of the capital, this is a linear scale, this is log-log scale, distribution of success, we found the 80-20 rule of Pareto, exactly. With this, from this simple rule, you have a power law distribution. Many people poor, and a very small number of people very rich. But let me explore if this depends on talents or on luck. If we plot the talent on the y-axis and the success in log scale on the x-axis, you see each point represents an agent that has some capital, some success, level of success, and the talent. If talent and success were correlated, we would expect an increasing function. So we'd expect a great number of points here, great talent, great success here, and the poor and the small number of points here. But you can observe that we have a uniform, quite uniform distribution of success, of talent as a function of success. So this means that you can find people with any talent with any level of success. Most of people have a level of capital that is similar to the initial one. This was the initial one. And you can see that the people with the smallest capital, smallest success, has a talent quite high, 0.75. The people with the maximum success, 2,050-60 units, against 0.00006 units, the max successful people, individual, has a talent very close to the average, 0.6. And you can observe, in inverting the scale, the axis, capital as function of talent. And you see that the richest people, highest capital, compared with the talent, you see that the richest people is around 0.6. So in the average. So you find average, and you see that the people with an average talent are very probably have a very big capital. So capital and success and talent seems not correlated. On the other hand, if you look at the distribution of capital and number of lucky events, or capital and the number of unlucky events, you see a strong correlation. People with very high capital are very lucky. So they have very green point by chance in their life. On the other hand, people with red points, with a strongly convergence of red points, are very small capital. So success and luck and unluck is very correlated. This is just to conclude the behavior of the capital as function of time of the most successful people with a talent 0.61, and he experimented just 80 events, 80 lucky events. He exploited all the opportunities, but he had the opportunities. That's important, by chance. And he exploited all the opportunities and becomes very rich, even if his talent is 0.61. On the other hand, the poorest individual with a talent, higher talent, experimented an incredible sequence of unlucky events. Just one lucky, but all unlucky. This is the results over 100 runs, so it's very robust, this result. And this is the final success over 100 runs. The most successful people has a talent exactly in the average, with 12 over 12 exploited opportunities. Okay, so let me make some tests, for example, that are correlated with our with this talk. For example, all of you know Jeff Bezos. Jeff Bezos is the owner of, the founder, chairman, CEO of Amazon. He became the world's wealthiest person 2 years ago, on July 2017, when his estimated worth increased to just $90 billion. Could you say what his wealth was just a year later, on July 2018? Clear? Possible answers. 100 billion, 110, 120, 130, 140, or 150 billions. 1 year later. So all his life for reaching 90 billions. In just 1 year, what is the capital? Please make your choice without looking on Wikipedia, please. Maybe after you can check on Wikipedia. So we can, I think we can close the votation. Oh, very good, very good. So you understand my presentation because, okay, we doubled the capital of our people in the simulation, and actually it's good. Actually, the correct answer is 115. So just in 1 year, so our rule that is not realistic. It's very realistic because rich people, you know the rule, the rich get richer. If you have $90 billion, it's very easy for you to double your capital next year. Otherwise, it's very difficult, of course. Another example, the last example, another sector in book, selling book. All of you know Joanne Rowling, the very famous Harry Potter and the Philosopher's Stone, one of the book, most famous book maybe in the last 100 years, in the sense of he sold billions, maybe millions of copies around the world. So all of you can suppose that the first editor who read this book said, "Oh, exceptional! Oh, the best book in the world! Oh, very great!" So we publish immediately. So the question is, can you say how many publishing houses rejected? Seems strange. Rejected the manuscript before Bloomsbury decided to publish it? There is someone that could reject the most famous book in the last 100 years? Please vote without check. None, 1, 2, 6, 12, 20. How many houses decided to reject it? I think we can stop. 20, 12. Good, very good. Another right point. Actually, the right answer was 12. So it's incredible, seems incredible. But it's not incredible that after many years became the most famous book. But before, it's difficult to predict success. Before that success is realized. That's the message. And let me close. Conclusion. From the micro point of view, of course, it's a very different situation. From the micro point of view, individual point of view, a talented individual has, by definition, a greater a priori probability to reach a high level of success than a moderately gifted one. This is included in our model, because you can exploit opportunity with the greatest probability from your individual point of view. But we show it that for a macro point of view, the a posteriori probability to find moderately gifted but very lucky individuals at the top level of success is greater than that of finding very talented but unlucky ones. So luck is more important than talent from the collective point of view. So what is the take-home message? From your point of view, what you can do? against this or to favor this, the role of luck? Of course, you cannot control the occurrence of luck events, but your best strategy is to broaden your activity to the production of ideas, communication with other people, meeting. You have to be an open-minded person. You have to keep in contact with many persons. In other words, to expose yourself to the highest probability to intercept opportunities, luck events. But this is a way. But another way is just to buy a ticket for the lottery. This is another way that is in line with this Congress. And let me thank you for your attention. Thank you. Also, name of my...
Thank you. Thank you. Molto grazie, Alessandro, Alessio, and Andrea. Thank you so much indeed. Thank you.